Hi, my dear students. Welcome to ME Educational Institutions. Today, we are going to solve some problems based on mechanical properties of solids. Here, we need to discuss stress and strain calculations in the wire when the body of mass m is attached to it and the body is in horizontal circular motion. Here, we need to calculate stress strain calculations in the wire. So let's start the session. Stress strain calculations, we need to draw free body diagram for dynamic bodies. When the body is in motion, we need to draw free body diagram. Then we can apply D'Alembert's principle in order to calculate the force acting along the axis of the wire, that is tension in the wire. For that, we need to draw free body diagram. Have a look on the table. Free body diagram is nothing but it's a diagram which represents all the forces which are acting on the body. That is nothing but free body diagram. In order to draw free body diagram, you should know some fundamental points. See this, force is a vector quantity. It is having both magnitude and direction. So first we can have a look on the different forces which is studied in physics. Weight equal to mg. It is gravitational force. It always act vertically downward direction. Tension in the string always pull the body. Normal reaction at contact surface always act perpendicular to the surface. And here in this session, you will be focusing on centrifugal forces. Centrifugal force always act opposite to the direction of centripetal acceleration, that is radial acceleration. Radial acceleration always act towards the center of the circular motion. Centrifugal force always act opposite to the direction of centripetal acceleration. That is why centrifugal force always act away from the center of circular motion. We can discuss one by one. Here I want to discuss one more point. This is the point. Centrifugal force always act opposite to the direction of centripetal acceleration. Centripetal acceleration also called as radial acceleration. Radial acceleration always act towards the center of circular motion. Centrifugal force always act away from the center of circular motion. At every point of contact or surface, two normal reactions will be acting. Both are equal in magnitude and unlike in nature. A force which is acting away from the node assumed to be positive, that is tensile in nature. Pulling force means the force which is acting away from the node, pulling the node, that is tensile in nature. The force which is acting away from the node assumed to be positive. Frictional resistance and inertia force always act opposite to the direction of motion of the body. These are the forces corresponding magnitudes and corresponding direction of forces listed in the force table. You will be drawing free body diagram entire course by using the force table. We are having different forces. First, you should know the force table before going to draw free body diagram. Once you understand this force table, you will feel comfortable while drawing free body diagram for corresponding system. See here, today I want to take one system and we'll see procedure to draw free body diagram. See here, this is the wire. I can say this is the wire. I can say that this would be wire of length. Wire of length L. A body of mass m is attached. a body of mass. Mass M is attached to the wire. This body is in circular motion. Radius of circular motion is R. This is the circular motion. We can call it as horizontal circular motion of the body. This particular body is in circular motion on the horizontal plane. So it is moving like this. Understood na? So it is moving on the horizontal plane. That is why you will call it as horizontal circular motion. R is the radius of circular motion. R would be the radius. L is the length of the wire. I can say L is the length of the wire. Length of the wire. Length of the wire here. So this would be theta. Theta from triangle AOB. Here you can write from triangle AOB. From triangle AOB, I can say that. What is sine theta? Tell me. Here, sine theta. Sine theta equals to OB by AB. OB by AB. You can confidently say that OB is the radius of circular motion. AB is the length of the wire. I can say here sine theta equals to R by L. Sine theta equals to R by L. Understood? So you will be using this result while applying equilibrium equations. Mass of the body M, length of the wire L, and R is the radius of circular motion. R is the radius of circular motion. Circular motion. This would be horizontal circular motion. Horizontal circular motion. Circular motion. Okay. So theta is the angle made by the wire with vertical. It is making an angle like this. You are measuring angle with the vertical theta. Understood na? You are measuring angle with vertical. Sin theta equal to R by L. Now we can see procedure to draw free body diagram. See here in what manner we are drawing free body diagram. Just observe. Here I want to take a free body diagram, means free body diagram. A diagram which is drawn for the body and it should be free. Okay. So that is why I divided all the parts, and this is the support. I can say this would be the support. Okay. Hinge support, I can say. Hinge support. This is the wire. This would be the wire. We need to draw free body diagram for the wire. Free body diagram for the body. Body of mass M. Body of mass M. You will be drawing free body diagram for the body and wire. I will tell you the procedure by using the table. See this. This is the circular motion. First you can focus on tension in the string. Tension in the string always pull the body. Tension in the string always pull the body. This tension pulling this body, this tension pulling the string. If it is theta and it would be 90 degrees, then it is 90 minus theta. Here tension always pull the body. This tension pulling the wire. This is the tension in the string. Tension in the string. Tension in the string. Tension in the string always pull the body. This tension pulling the wire. This tension pulling the this particular support. Here it is what? Reaction at the support. Reaction at the support. Reaction at the support. Understood na? I can say that RA equal to tension in the string. That is the reaction at support. Here force is acting at this point. This RB. The force which is acting away from the node, assumed to be positive. This is also T. Okay. Tension in the string. At this point, two tensions will be acting. At this point, two tensions will be acting. Both tensions are pulling the body. Okay, so here this tension pulling this body, this tension pulling the wire. Tension always pull the body. Next, weight always act vertically downward direction. Weight of the body always act vertically downward direction. Next, centrifugal force always act away from the center of rotation of the body. Centrifugal force, this is mass of the body M. Okay, centrifugal force always act away from the center of rotation of the body. This is the body. Understood na? So this is the free body diagram for the body. Free body diagram for the this particular wire. Now I can say confidently what kind of stresses induced in the wire. I can say that tensile stresses induced in the wire. Tensile stresses induced in the wire. Induced in the wire. I can say this should be the wire. Wire AB. What kind of stresses induced? Tell me. Here it would be what kind of stresses? Tension T. This would be the tension T. Tension T. This is the tension T. This would be the tension T. What kind of stresses induced in the wire? Sigma AB equal to how much? What is sigma AB? Tension in the string. Sigma AB. This is tensile stresses. Here load acting on the wire. Load acting on the wire, tension in the string by area of cross section. This is tensile in nature and it is positive. I can say this is tensile in nature. Okay, tensile in nature. Tensile stresses. Understood na? So this is the way to calculate, draw free body diagram and deciding nature of the stresses in the wire. Okay, tensile stresses induced. We can resolve it. T, you can resolve this. T cos 90 minus theta. T sin 90 minus theta. Here it is what? Tension in the string. I can say this is the tension in the string. What is T here? Tension in the string. Tension in the string. Understood? So here T sin cos 90 sin 90 minus theta means what? T cos theta. Here it is what? T cos theta. What is T cos 90 minus theta? T sin theta. Here you will be getting T sin theta. So this is the way to draw free body diagram. In textbooks, generally people will draw like this. They will be focusing on free body diagram for the body only. So here, first, weight of the body always act vertically downward direction. The force which is acting away from the node assumed to be positive. This is the tension in the string. Tension in the string. Tension in the string. tension in the string. Centrifugal force always act away from the center of circular motion of the body, away from this. And here you will be resolving it like this. You resolved it. Understood na? T cos theta, and here it is T sin theta you will be getting. Now we can separate. You can separate, if you want to see properly, this is tension in the string. We already know that. Here, like this. T sin 90 minus theta means T cos theta. T cos 90 minus theta means T sin theta. They are not focusing on free body diagram on the wire and free body diagram at the support. Please don't confuse. Understood na? So here this tension, this is actual free body diagram. Please don't confuse. Here this would be the actual free body diagram. We need to separate all the bodies and we need to represent all the forces which are acting on that corresponding body. Here you need to separate the wire, you need to separate the body, you need to separate the support. So then once you start drawing free body diagram, first statement, weight always act vertically downward direction. Mass of the wire neglected. Weight always act vertically downward direction. Centrifugal force away from this. Tension at this contact point, two normal reactions will be acting. One is here tension in the string and reaction at this point. So once you combine, reaction equal to tension in the string. Okay, these two are tension in the strings. Then at this point, reaction at this contact point, support, that is the support reaction, and tension in the string, both becomes equal to Ra equal to T. Both are equal in magnitude but unlike in nature, opposite direction, both will be acting. Understood na? Both are equal in magnitude. Tension always pull the body. These two tensions are pulling, that is why you are calling it as tensile stresses induced in the wire. In order to give this statement, I have drawn free body diagram for the wire separately. To solve the problem, free body diagram for the body is enough. Okay na? This body is enough. FBD for the body is enough. Now we can take free body diagram for the body of mass M. Weight always act vertically downward direction. This is the tension and centrifugal forces. This is the free body diagram. Now we can resolve the forces. You can resolve it. Then apply D'Alembert's principle. I want to say one thing. I am interested to apply D'Alembert's principle. That is why I represented centrifugal forces in the free body diagram in order to convert dynamic problem into static problem. Here I represented centrifugal forces. Okay, in order to convert, this is the centrifugal force. Centrifugal force. Centrifugal force always act opposite to the direction of centripetal acceleration. I represented centrifugal force in the free body diagram means it is acting opposite to the direction of the acceleration of the body. That means total motion of the body is nullified by representing centrifugal force in the free body diagram. So dynamic problem converted into static problem. So entire diagram is for static problem. That is the condition of D'Alembert's principle. The main purpose of D'Alembert's principle is used to convert dynamic problem into static problem. What is the procedure to convert dynamic problem into static problem? Here is, you need to represent inertia force. It is the inertia force in circular motion. Understood na? For linear motion, you will be representing inertia force in the free body diagram. In order to convert dynamic problem into static problem, inertia force always act opposite to the direction of motion of the body. In circular motion, you are representing centrifugal force opposite to the direction of centripetal acceleration. That means motion of the body, circular motion of the body is nullified by representing centrifugal force in the free body diagram. This is the way to convert dynamic problem into static problem and procedure to apply D'Alembert's principle. Straight away you can apply static equilibrium equations. Here sigma h equals to 0. Here I want to write sigma h equals to 0. Sigma h equals to 0 means what? Sum of the left forces equal to sum of the right forces. This is nothing but how much? T sin theta. T sin theta. Here you can write T sin theta. Confidently, sum of the left forces equal to sum of the right forces. T sin theta equal to centrifugal force. So here T sin theta equals to m r omega square. Here sin theta we already know that. What is sin theta? What is sin theta? Sin theta equals to R by L. Sin theta equals to R by L. We can substitute T. Here it is what? R by L. Equals to m r omega square. M r omega square. Omega is the angular velocity of the body, which is in circular motion, horizontal circular motion. Here R gets cancelled out. You can cancel this R and this R. R will get cancelled out. What is the tension in the string? T equal to m omega square L. Tension in the string is obtained. That is equivalent to m omega square L. See here, this would be tension in the string. Tension in the string. Tension in the string. Understood? So it is very simple. So finally we got tension in the string m omega square L. Now we can calculate angular velocity of the body which is in horizontal circular motion. So how to calculate angular velocity of the body? Just now we calculated this part. Here we know that we applied that part, sigma h equal to 0. Sigma h equals to 0. Then what we did? T sin theta equals to m r omega square. What is omega square here? Omega square here T sin theta by m times r. M times r. We already know that sin theta equals to r by L. Sin theta equals to r by L by m times r. Here you can cancel these two r's. R gets cancelled out. This is the r and this r gets cancelled out. Finally, how much you are getting? Omega square equals to T by m times L. Omega equals to square root of T by m times L. This is the angular velocity of the body. Once you know angular velocity, you can calculate the time period. We know this 2 pi by t. Omega equal to 2 pi by t. So we know omega equal to 2 pi by t. T is the time period of the circular motion. So square root of T is the tension in the string, mass of the body and length of the wire. Finally, what is T? Tell me. What is T here? This would be time period. Sorry. Here you can take small t because tension in the string, capital T, small t is the time period. Here you can take time small t. You can take small t is the time period. Time period t equal to what? 2 pi square root of m times L by tension in the string. T, capital T is the tension in the string. So here you can take 2 pi f also. Here omega you got square root of T by ml, angular velocity of the body. You can write it as 2 pi f. F is the frequency, square root of T by ml, square root of T by ml. F equals to 1 by 2 pi, 1 by 2 pi, square root of tension in the string by mass of the body into length of the wire. So these are the results obtained. So here what is omega? You can write one by one. Here omega equals to angular velocity of the body. Here you can write angular velocity of the body. Angular velocity of the body. Angular velocity of the body in radians per second. Here it is radians per second. Next, T is the time period. Here you can write it as time period of the body which is in circular motion. So time period. And F is the frequency. F is the frequency. This is in seconds. This is in hertz. Understood now? So in this manner, we will build the expressions. Here important expression while solving problems is nothing but angular velocity of the body. Angular velocity of the body. So which is in horizontal circular motion. Tension in the string. T. Tension in the string. What is the tension in the string? Here I can say what is the tension in the string. This is the tension in the string. How much is obtained? Tell me. M omega square L. So this is the tension in the string. Tension in the string. Tension in the string equal to m omega square L. Angular velocity of the body equal to square root of T by ml. So this is the free body diagram. So this is the free body diagram for the body. We are small t equal to 2 pi square root of ml by t. Now we can see we can solve this problem by using Lami's equation also instead of applying equilibrium equations. Straight away you can apply Lami's equation. This is the free body diagram. బుజ్జులు ఇవన్నీ వదిలేరా ఇప్పుడు రికార్డింగ్ చేసేటప్పుడు ఇవన్నీ పెట్టుకుంటే ఎట్లా డోర్ అయితే తీయొద్దు బుజ్జులు అట్లా అంటే ఆ సౌండ్ వస్తుంది. థ్యాంక్ యూ బుజ్జులు. We can solve this problem by applying Lami's equation also. Procedure to apply Lami's equation for three concurrent forces at a point B. Apply Lami's equation at point B. This is the static problem and static equilibrium equations. we applied centrifugal force, we converted dynamic problem into static problem. In static equilibrium condition, three forces acting at a point and are in equilibrium. Then each force is proportional to the sine of the angle between other two forces. You can apply Lamis equation here. T by what is the angle between other two forces? What is the angle between other two forces, FC and MG? This is 90 degrees. T by sine 90 degrees equivalents to here centrifugal force FC. Here I can say that centrifugal force FC by sine of the angle between other two forces. Here it is the sine of the angle between other two forces, tension and mg. 90 minus theta plus 90, how much? 180 minus theta. So sine 180 minus theta you will be getting. What about mg? mg by sine of the angle between other two forces. mg by sine of the angle between other two forces, 90 plus theta, sine 90 plus theta, sine 90 plus theta. You can equate these two from Lamis equation. T by sine 90 equal to fc by here t by 1 sine 90 equal to 1. fc is nothing but centrifugal force m times r omega square sine 180 minus theta, second quadrant. Here you will be getting sine theta equals to mg by sine 90 plus theta. Here it is how much? Cos theta. 90 plus theta, second quadrant, 90, sine becomes cos. mg by cos theta. So you can equate these two. T equivalents to what is obtained? mr omega square by sine theta. mr omega square by sine theta. Here sine theta equal to r by l. Tension T equal to mr omega square by r by l. mr omega square by r by l. r gets cancelled out. Tension T equals to m omega square l. This is the tension in the string. Here it is what? Tension in the string. Tension in the string. Tension in the string. From here, omega equal to how much? How much is obtained? Omega equal to how much is obtained? Here T by ml. T by ml. So from here, what is this? Here you can write T equal to mg by cos theta. mg by cos theta. T equal to mg by cos theta. You can write like that also. Here cos theta is nothing but what is that? Square root of L square minus R square. mg by square root of L square minus R square from the triangle. Okay, like this also we can discuss, but this is popular. Straight away you will be getting. Length of the wire is given, mass of the body will be given. So like this we can solve the problem. M omega square